Hi, have you ever wondered about how this 69-kilogram heavy robot is able to move? No? We are Inmoov Reloaded and we are a robotics team from Austria. Now we will explain our project to you. In our performance, we are playing rock, paper, scissors with our robot named Joe. Firstly, he will follow the playing person to the place where the game takes place. With a voice command, the game is started. Our robot is based on an open source project which was developed by a French designer. It is the first open source 3D printed life-size robot. More so, was the creator a designer, not an engineer, so there were a lot of troubles and inconveniences. Now we are going to show you the capabilities of movement, starting with the head. It can be rotated at the neck, left and right, as well as tilt up and down and side to side. As you can see, the eyes light up as well.
There is a total of 6 servos in each hand, 5 dedicated to the fingers and 1 for the rotation of the wrist. Each finger can be moved separately, allowing the hand to show different gestures. For a better movement of the arm, we have redesigned the bicep. This way it's more reliable and durable than the original design thanks to the usage of ball bearings and proper lead screws. Overall, the shoulder actuator can move the arm forwards and backwards, turn the arm and angle the elbow using the bicep actuator. The shoulder is now controlled by a purpose-built active motor controller board. Those controllers receive commands directly from the main controller and position the according actuators themselves. It's also possible to move the torso, for example by tilting it from side to side. With the hip joint we can rotate the torso of the robot to give it a more humanoid movement set.
Below the robot's feet is a movable platform, allowing it to drive around the stage. This is made possible by the use of 2 independently controlled hub motors. If transport of the robot is required, a joystick can be attached to easily maneuver said platform. Now each team member is going to present their role in the project, starting with myself. I am Thomas and I'm 15 years old. I am programmer of the main steering part used to move Joe. My biggest task was to create a terminal used to steer and act with our robot. To do that, I designed one using the programming language Python. The terminal features multiple menus: steering motors, monitoring values, showing gestures, and much more. Showing gestures being the biggest task because of a few protocols and a library needed to be implemented. For example, the recognition of each Arduino by USB, used to assign them to their according tasks in the program.
Hi, I'm Markus. I'm responsible for the mechanical design and upkeep of our robot. The robot, as already mentioned, is an open source project which had some out-of-the-box problems in regard to some mechanical systems. For example, the upper arm. The original version of the Inmoov robot had an actuator that couldn't handle the pulling force it needs to put out. Therefore, I designed one that can. Another example that has changed in comparison to the original is the head. This minor change didn't happen out of necessity, but to get the robot to look more human-like. The face itself is made from latex, the structure beneath is made from acrylic plates and metal. Another problem I had to tackle was that we couldn't order the originally used potentiometers. Therefore, I came up with a way to use standard audio equipment style potentiometers.
I am Manuel, and I am responsible for the electrical system and hardware level programming. The original design used modified servo motors as actuators. Those motors got a new version from their manufacturer, which made them impossible to use. So I designed our own motor controller board, which is capable of controlling up to 4 motors based on up to 2 potentiometers per motor. Because of the new boards, I also had to write a new C++ program to accurately and fast position each actuator.
Besides that, I also implemented PID controllers for the platform, allowing the follow me performance to work more smoothly.
Hi, I'm Andrea, the programmer for the recognition and therefore responsible for 2 of the chosen features, one of them being gesture recognition. We achieved this with our Intel RealSense depth camera. It provides us with the necessary information to play rock, paper, scissors, so that the robot can register the outcome of the game. It is only natural to ask for a game instead of a starting gesture, so we implemented voice recognition which detects a keyword. This is our second feature, the movement of the platform being the third and the movement of the upper body being our last feature. This was our technical video demonstration. I hope you enjoyed and thank you for your attention.